Let's take a look at my next binomial in this case that needs to be factored. First of all, whenever you have a binomial, it has to be one of two things. Either this is the difference of two squares or it's the difference of two cubes. If it's not one of those two things, it won't factor. Not only that, but I want you to notice that there is no common factor. My second term has only z's, and there are no z's to factor from the first term. So of course there's no common factor. The two terms that remain are either the difference of squares or the difference of cubes. Well, let's take a look. Given that I have a 36, 36 does not have a cube root. Neither does y squared. The z to the sixth could either be a square or a cube, but since this one can only be a square, this must be the difference of two squares, and let's literally rewrite this as squares. If I take the square root of 36, I get 6, and if I take the square root of y squared, I get y. So in other words, 6y squared can be written as 36y squared, and z to the third squared can be written as z to the sixth. So I now am demonstrating literally that I have the difference of two perfect squares. To factor this, the first parenthesis, I merely take off the squares, which leaves me with my 6y minus my z cubed. My second parenthesis is exactly the same as the first parenthesis, except the minus becomes a plus. And I've now successfully factored the difference of two squares. Let's take a look at our third problem. Once again, I have a binomial. That means it has two terms. It must be, since it's a subtraction problem, either the difference of two squares or the difference of two cubes. Now notice again the problem with the first term. The square root of 64 is 8, but the cube root is 4. I could take the cube root of x to the sixth or the square root. So the first term is actually both a perfect square and a perfect cube. But in this case, look at the second term. 27 does not have a square root, an even square root, but it does have an even cube root. So this must be the difference of two cubes. So if I rewrite this as cubes, the cube root of 64 is 4, and the cube root of x to the sixth, if I take 6 divided by 3, is 2. Working backwards, notice that 4 cubed is 64, and x to the second to the third is x to the sixth. And the cube root of 27 is 3. 3 to the third is 27. Now, cubes are a little bit different than squares. For my first parenthesis, I will once again merely remove the cubes. Notice my first parenthesis then is simply 4x squared minus 3. The second parenthesis is a little trickier. The first term is actually taken by finding the square of the first term of the first parentheses. In other words, in this case, 4x squared squared is 16x to the fourth. You can think of this is that you have 3 of this term to end up with. I put one of them here, 2 of them there, and when I multiply those two together, I have all 3 of my 4x squareds. So again, the first one is the 4x squared. This one would be 4 squared, 16, x squared squared, x to the fourth. And of course, if I take 4x squared times 16x to the fourth, I get my very original 64x to the sixth. My second term, again, I merely took off the cube, so I have a 3. To find my last term, once again, I just merely square the 3. Negative 3 squared is positive 9. The trick is the middle term. The middle term is the product of the first two terms. In other words, these two terms in the first parentheses, if I multiply them together, negative 3 times 4x squared is negative 12x squared. But what you always must do is switch the sign on the middle term. Had this been a positive, then this would have been a negative. Since this was a negative, it's now a positive. And I now have the result. When I take the first terms and multiply them together, I get the first term of my original problem. When I take the last terms and multiply them together, I get the last term in my original problem. I will let you verify by using the distributive property that all four other terms actually just cancel out. Let's take a look at our next problem. In this case, I once again have a binomial, two terms. However, you'll notice this time it's the sum of two terms. Therefore, if this is to factor, it must be the sum of two cubes. And in fact, if it's not the sum of two cubes, then it doesn't factor at all. And I keep leaving this step out, but it is important to observe that there are no common terms that can factor out of this. If there were, that would actually be my first step. But once again, there's no common terms. It's the sum of two terms, so if it factors, it must be cubes. And you'll notice that all the powers are indeed a product of 3 and some number, or a multiple of 3 if you will. So this does indeed become the factor of two, the sum of two cubes, Then, to factor it, let's first rewrite these as cubes. My first one, if I divide by 3, I get 2. If I divide by 3, I get 1, which I don't even have to write. And 12 divided by 3 is 4. And of course, what I'm doing there is finding the cube root. Working in reverse, please note that x squared cubed is indeed x to the 6th. Y cubed is of course just y cubed. And z to the 4th to the 3rd is indeed z to the 12th. 1 to any power is 1. So once again, I do indeed have the sum of two perfect cubes. To factor, once again, I merely take off the cubes and I have my first parenthesis. So I have x squared y z to the 4th plus 1. Remember how I find the terms in my second parenthesis. You follow the same pattern with the sum of cubes as we did with the difference of cubes on the last problem. If I square my first term, I have the first term of my second parenthesis. If I square my last term, I have the last term of my second parenthesis. To find the middle term of this trinomial, I take the product of the original two terms from my first parenthesis. 1 times x squared y z to the 4th is merely x squared y z to the 4th, because remember, 1 is indeed the multiplicative identity. But don't forget, the answer really isn't positive 1 x squared y z to the 4th, because we need to make a sign change always on this middle term. Since this was a positive, this one would be a negative, and I therefore have my answer.